Hi everyone, welcome to another quick session. In this session, we will discuss application security controls. Application security controls with real world examples and CISSP exam insights. Application security controls, these are defenses built into software and infrastructure to protect against attacks such as injection, cross-site scripting, and data exposure. For the CISSP exam, we need to remember these four pillars: input validation, web application firewalls, database security, and code security. So, as I said, these are defenses which are built into software and infrastructure to protect against attacks such as injections, right? So, if we talk about input validation purpose ensure only expected and safe input is processed by the application. It prevents attacker from inserting malicious commands or SQL injections, right? So if the input is not validated, a login form might interpret this as true and allow unauthorized access, right? So validation is very important. Good validation practice accept only known safe patterns, whitelisting, reject anything outside expected format, for example, only numbers for an age field. That could be an example, right? So defense against injection attacks, SQL command injections. So exam tip: input validation defense against injection attacks. The second is web application firewalls. It filters and blocks malicious HTTP requests before they reach the application. So it blocks all kind of malicious HTTP requests before they reach to the application. So these are web application firewalls, WAFs. Example: an AWS WAF blocks suspicious traffic patterns such as SQL injection strings or cross-site scripting scripts in the URLs. So what could be the best defense against common web attack, cross-site scripting, SQL injection, um, cross-site forgery attacks, right? CSRF. And if they talk about WAF, then it works on network layer network. It is network shield for web apps, but not a substitute for secure coding, right? The next one is database security. Database security, it protects a database from unauthorized access or data leaks. So parameterized queries, prepared statement prevent SQL injection, right? For instance, uh, encryption protect data at rest and in transit. Uh, Least privilege application accounts get only the minimum required permission. Defense against injection attacks, data breaches, insider threats. So database security uses least privileges plus encryption. So this is the way we can protect it. Next one is code security. Code security, its purpose ensures software itself is written safely without exposing sensitive info or weak logic. best practices, no hard code credentials, for example, API keys or passwords, implement proper error handling, show generic error messages instead of database details, use trusted and updated libraries. For example, DB passwords, we are not used to use simple and basic password. For instance, admin123. Use secure vault or environment variables for secret. Defense against information leakage, credential theft, code exploitation. Code security, no hard-coded credentials, plus secure error handling. So now if we conclude it, um, input validation, check and sanitize users' input. Reject any query or any data which is not valid. A defense against injection attacks and defense for injections, right? So this is exam tips. If they talk about injection attacks, so that is input um, validations. So defense against injection attacks and defense or injection. If they talk about an exam, um, defense or injection, that is, we need to implement input validation. Um, Web application firewalls, filter HTTP traffic, AWS, WAF blocking, SQL injection, web attacks. It has defense against web attacks and it provides network layer protections. Database security protects stored data, use prepare um, prepare statement, data leaks, injection, least privileges plus encryption. Code security, write safe code, remove hard-coded password, info disclosure, errors, secure coding plus error handling. So input validation stops bad data before it enters. WAF blocks attacks at the network edge. Database security limits damage if inputs slip through. Code security ensures no secret or vulnerability exists in the app. So the next one is secure coding practices. Secure coding practices, another essential CISSP topic from the software development security domain area. Definition about secure coding practices are methods developers use to reduce vulnerability while writing software. For the CISSP exam, we need to focus on avoiding insecure practices, proper error handling, memory safety. So what it means, no sensitive information in comments. So very important. Never leave, it means never leave sensitive information in the comment section. Never leave passwords, API keys, or credential in secure code or comments. If an attacker gains access to secure code, for example, via GitHub leak, they can immediately use those credentials. Good practice don't include secret in code or comment. Store credentials securely, for example, in encrypted vaults or environment variables. CISSP focus sensitive data in comments or code information disclosure risk, right? Sensitive data in comments are code information disclosure risk. So proper error handling. Application must show generic error messages to user, detail logs only to the admins. So this give attacker, for example, if there is an error, DB connection is failed on port 5432. This gives attackers valuable info about the backend. So the good the good error message would be login failed, please try again. So we are not supposed to provide the clear information um, in error message, so that could give an hint to the attacker. Error messages must not reveal internal systems details like server names, database types, file paths. So avoid hard-coded credentials. As we discussed, never embed password tokens or keys directly in source code. If the source is leaked, attacker can misuse the credential. So best practices: use AWS Secret Manager, Azure Key Vault, or environment variable. Rotate credential regularly. Um, so exam tip is hard-coded credential, major violation of secure code principles. Next one is memory management. What it means: ensure software safely allocate and freeze memory. Improper memory handling leads to buffer overflow, memory leaks, or dangling pointers. So validate input size before writing to memory. Use safe functions. Uh, Always use safe functions. Clear memory after use to prevent leaks. So exam tips: never expose sensitive data in comments. Hard-coded credentials. Error message must be generic. Memory safety is critical, especially in some languages, programming languages in C, C++. Use secure storage, vaults, key managers, environment variables. So that is a quick discussion about all these important topics. I hope I would be able to explain about those topics. Thank you so much for watching this session. If you have any question or feedback, please share in the feedback section. Thank you so much.